Okay, so take your TV remote, right? Turn the TV on, and then try to press 4 or 5 buttons on the TV remote at the same time. And then come back and tell me what happened. Today, we are going to be talking about the soul of gadgets, devices, and robots, right? When I say that, what I mean is, what is it exactly in these electronics and devices that really makes them work, right? If you've ever observed your surroundings, you must have seen different gadgets like smartphones and computers and televisions and microwaves, washing machines, all these different things, right? And like at some point in your life, you might have wondered, like, how does this actually work? Like, what is going on inside this that it makes the decisions, right? So this is exactly what we will be talking about today. I'll give you a very simple example. Have you noticed, like, if you put a car in reverse, if a car is backing up, if the car comes near a wall or another car or a person, immediately there's an alarm that goes off and the driver is alerted that there's an obstacle behind you should stop. Have you noticed that?
Yeah.
So all modern cars have this feature where the moment they detect something behind them or close to the edges, top or the front or behind, they immediately alert the driver with a buzzer, right? So if you think about it, there's so many different things happening in the background to make that happen, right? What happens is you have sensors on your car that are present all around the bumper, right? Behind and the front. And these sensors are constantly collecting data. These sensors are always measuring the distance between the car and potential objects that are in front or in behind or on the sides of the car constantly, right? The moment these sensors notice that there is an object that comes dangerously close to the car, suddenly you'll see that an alarm goes off and the driver is alerted, right? So basically, in this session, we will be trying to we'll try to find out what is actually behind the functioning of such devices, right? Let's take the example of the human body. Now, let's say that your mom prepared a cup of hot chocolate for you, okay? And it's lying there on the table and it's fresh and it's piping hot. Like you can see the steam coming out of it, right? And you go to grab that cup of hot chocolate, but the moment you touch the cup, immediately it's so hot that you pull your hands away, right? So, which part of your body is making that decision to pull away from the cup?
I'm not sure.
Like, you don't have to think about it, but like, which part of your body makes that decision that, oh, hey, this cup is really hot, I should not touch it?
The brain?
Exactly. Of course, it is the brain. So similarly, electronics also have an artificial brain, which can be in the form of a microcontroller. Okay. So to keep things simple, I'll explain to you what a microcontroller is first. A microcontroller is basically a small electronic circuit which has a bunch of parts built in it. Okay, that's the simplest definition you can get. So that is what an integrated circuit is. Now, you might be wondering, what is an integrated circuit, right? An integrated circuit is basically a collection of electronic components that are present all around you. So from your television remote to your air conditioner to your refrigerator, there are integrated circuits everywhere. And the microcontroller is a type of integrated circuit. Okay. In a typical microcontroller, you are going to find these 4 parts always, no matter what microcontroller it is. So every microcontroller will have a CPU, it will have RAM, it will have ROM, and it will have I/O pins. 4 things. I'll explain these one by one. So the CPU is actually, it stands for a central processing unit. This is the brains of the microcontroller. This is where all the calculations are done. This is where all the decisions are made. This part, the CPU, is where the magic happens, okay? It's like the brain. And then every computer comes with 2 kinds of memories. You'll have RAM and ROM. Uh, RAM stands for random access memory, and ROM stands for read-only memory. Whenever we are talking about storage of any kind of device, we're talking about the ROM, the read-only memory. So when you see a phone or a tablet or a laptop or a computer that says it has 128 gigabytes of storage, so that means it has 128 gigabytes of read-only memory, right? And interestingly, RAM is the different type of memory, which is random access memory. So RAM is kind of cool. What RAM does is RAM is like a temporary storage of memory, right? What RAM does is RAM goes into the ROM and it pulls data from the ROM and gives it to the brains, the CPU. So RAM is like a messenger, okay? The 4th part that you see here that says I/O pins, this is really interesting. So I/O stands for input and output. So basically, these pins are like add-on features. They let you add different electronical components on your circuit. So remember in the activity that we did, we added an LED to the circuit. We made it glow up, right? The activity that we did, the in-class one. So that LED that we added was added to the I/O pin. So any microcontroller that you come across is usually going to have these little pins that you can attach little electronical components into, like LEDs or motors or resistors, wires, all these different things you can attach, okay? So the I/O pins are basically what allow you to interact with the outside world. Now, the only limitation that microcontrollers have, the only problem that exists with microcontrollers is that they can only do one task at a time. So, do you have any kind of remote near you, like a television remote or a any kind of remote?
No.
No. Uh, w- is your television in your living room or something?
Yes.
Can you go try something real quick?
Okay.
Okay, so take your TV remote, right? Turn the TV on, and then try to press 4 or 5 buttons on the TV remote at the same time. And then come back and tell me what happened. So you notice that you mashed a bunch of buttons, but like the TV did not do all of the things, right? It only did one thing, right? So your TV remote has a microcontroller, and just like every other microcontroller out there, it has limitations that a microcontroller can only do one thing at a time. Now, the one of the most popular circuits out there that contains a microcontroller is the Arduino. Notice these little pins on the top, these little like squares. These are the pins that I was talking about. These are the pins where you attach like LEDs or wires or sensors, right? Arduino is actually one of the most popular microcontrollers amongst beginners as well as professionals. So this makes the hardware really unique. And the reason why the Arduino was created was because the people that created Arduino, they wanted to launch something cheap that allows students like you to learn coding and get started with coding, right? So how does this thing even work? Basically, what you do is you write a program on your computer, right? And you attach this Arduino to your computer and you upload that program into the memory, the ROM, the read only memory of the Arduino. Okay. Once your program is uploaded onto the Arduino, you can disconnect it from the computer. And now every single time you power on the Arduino, it's going to run that program that you uploaded on it. So the Arduino was launched in 2005, and it was launched as a very cheap and available, accessible platform for school students and for teachers to teach coding to kids, right? That was the idea. Let's talk about the basic parts of the Arduino. Okay. Now you have the USB ports on the left side. Here is how you power the Arduino, or you connect it to the computer. On top, you have the digital pins. Here, remember, here is where we attached the LED last time, right?
Yep.
Then in the center, the middle part here it's called a microcontroller. These are the brains. Remember, we just talked about microcontrollers?
Yep.
Then you have an onboard LED that lets you know that your program is working. You have a power LED that you know it's powered on. You have a reset button. And on the left side, you have a power connector. On the bottom, you will notice that there are power pins and analog pins. So these also let you power the different things that you attach to the Arduino. The Arduino that we just worked on is called the Arduino Uno, right? That's the most common and most popular Arduino out there. That's the one that's most easy to find. The Arduino Uno comes with 14 digital input and output pins. Okay. Then you have the Arduino Leonardo. The Arduino Leonardo has a built-in USB, and it has 18 digital input and output pins. It's got 4 more than the Arduino Uno. So basically, the Leonardo is a little bigger, and it allows you to attach different electronical components onto it. The Arduino 101 is a little cool. If you look at the picture, it has a little Bluetooth icon on it, the Arduino 101. Now, this means that the Arduino 101 has Bluetooth built in, and that allows you to control your circuits with an app, right? So basically, why do people even work with the Arduino? The Arduino is very popular among students, among people who are prototyping electronics, people who are trying to create new products, people who are doing robotics. So the Arduino has so many different uses, and that's why you have so many different kinds of Arduinos. The Arduino Nano is a small, very compact board. It's got all the features of a regular Arduino, but it's really small. And usually, this kind of Arduino is used in projects where you do not have a lot of space to work with. Okay. And then finally, you have the Arduino Micro. The Arduino Micro basically is used whenever you need the Arduino to be recognized as an input device for a computer. So you know how when you connect a mouse or a keyboard to a computer, the computer knows that your mouse or keyboard is an input device. You're going to input data from your mouse and keyboard to the computer, right? So when people are making projects that they need their project to be recognized as an input device, they use the Arduino Micro because it can be recognizable as a mouse or keyboard. It has a built-in USB, and it has 20 digital input and output pins, more than any Arduino out there. Okay? So now if I was making a smartwatch or like a smart fitness band, like something like the Apple Watch, which Arduino would I use? Which one of these would I use? This brings us to the next topic, which is the Raspberry Pi. So now you know all about the Arduino, and now I will introduce you to the Raspberry Pi. Okay. So the Raspberry Pi is actually a really small single board computer. It's a mini computer. It's called an SBC, a single board computer. What that means is that everything that you need on a computer to make it a computer is all present in this one small credit card sized board, right? All the components that a proper computer would need to function, everything you have is on a single board. And this was created by the Raspberry Pi Foundation in 2012 in order to promote coding and exploration in electronics in schools. And the Raspberry Pi it originates from the UK, and it's basically used for a lot of the things that the Arduino is used for. So like robotics and electronics applications, all these different things. Now, the cool part about the Raspberry Pi is, like the microcontroller, the Raspberry Pi has a microprocessor. So this is a new term, right? A microprocessor is very different from a microcontroller. So a microprocessor is something you find in phones, something you find, like, you remember how I told you your television remote has a microcontroller,
Yeah.
right? But your computer right now, the one you're sitting on, or your phone or your tablet, is going to have a microprocessor. It's not going to have a microcontroller. Okay? So unlike microcontrollers, microprocessors are extremely good at multitasking. That's why you can listen to my voice on Zoom, you can go on Tinkercad, you can check your WhatsApp, you can maybe paint something, all while attending the online class, right? So basically, a microprocessor allows you to do a lot of multitasking. The Raspberry Pi, like I said, it's a full mini computer. You can connect this board to an external television or a monitor, and you can use the USB ports to connect it to a mouse and a keyboard, and bam, you have a full computer. It also has built-in Wi-Fi and a Ethernet port to connect it to your Wi-Fi router directly. And what this does is it turns this little thing into a full computer. You literally can play games, watch videos, edit documents on this thing. And the Raspberry Pi 4, or like, this thing barely costs $50. Like, there's no computer in the world that is that cheap, right? So these are the parts of a Raspberry Pi. The main parts that you need to know about are these pins on the top. Remember, Arduino had pins? So similarly, the Raspberry Pi also has pins, and these are called GPIO pins, general purpose input output pins. On the center here, the marked circle is the microprocessor. It's the brains of the computer, right? On the right side, you have the USB ports. And on the bottom right, you have the Ethernet port that lets it connect to the internet. And on the bottom here, which says HDMI, this lets you connect your Raspberry Pi to an external display like a monitor or a television.